Hello everyone, so welcome to the full revision series. In this video I shall be dealing with the full revision of the electrochemistry chapter for JEE and NEET. So first of all, you can see that we have taken the poll and electrochemistry was the topic which I had won previously. So that is why this topic has been taken here. So make sure you subscribe to the channel and click on the bell icon in order to receive the notifications so that you don't miss the future uploads whatever I do, and moreover the voting which I take. So let us begin with this very important video here. So if you actually don't know that how the Nernst equation is actually derived, let me write it for you. It is derived with the help of delta G is equal to delta G naught plus RT ln Q. Okay, basically further whenever the Nernst equation comes out, it is written as E is equal to E naught minus 0.0591 upon N log of Q to the base 10, where Q is the reaction quotient. I shall be using this in the particular question which is going to be discussed, so make sure you try to understand it very well. The question here is that you need to calculate the E cell for platinum solid, which is basically just a material which is present for the hydrogen electrode. H2 is a gaseous form, so that is why we have been given 1 atmosphere. We have HCOOH, which is the formic acid, some concentration C1 and Ka1 has been mentioned. Then we move on to the another electrode. We have CH3 C double bond OH, C2 Ka2, H2 1 atmosphere platinum solid. Let us try to understand. See, this question is taken because जब मैं student था, to be honest, whenever I used to see so many, these type of sticks there, the electrodes, I used to get very scared. So that is why I've taken the first question here to make you feel comfortable with this video. So try to see that what is the actual reaction happening here. This is a very good combination of the electrochemistry and the ionic equilibrium also. So try to make it very clear to you. So we have H2 here, which is in the gaseous form, which goes into H plus electron in this state. Why? Because we have HCO, O minus plus H plus. So basically we are getting H plus from this particular part. That's why it has been given to you. So basically 2H plus and 2 electrons in order to balance the equation which has been given here. And this reaction is actually occurring at the anode because the oxidation is happening from 0 to +1. Now what is the reaction which is occurring at the cathode? You can see very well we have CH3 C double bond OH. So that can be written as CH3 C double bond O minus and H plus from here. Okay, so this acid which has been given, we get H plus which is going into H2. So you can guess that reduction is happening. So H plus electron would give me H2. So balancing this equation, we get this to be the equation at the cathode. Okay, so the first mission, whenever any electrochemistry question has been given to you, you should try to write the anode and the cathode half cell reactions. Now let us try to do the ionic equilibrium which is happening. We know that HCOOH would go into HCOO minus and H plus. It is a weak acid. Why? Because Ka1 has been given. जब भी Ka1 दिया होता है, it means it is a weak acid. At time t is equal to 0, the concentration has been given as some C1. At any general time t, the concentration becomes C1 minus X and X and X. Okay, I hope this point is clear to you. From here, the value of Ka1, that is the equilibrium constant, would be equal to X into X whole upon C1 minus X from here. That basically comes out to be equal to X square upon C1, because we can ignore X with respect to C1. So from here we get the value of X to be equal to root of C1 Ka1. Let this be the equation number 1 for this particular case. The second case is the acetic acid. So acetic acid, that is CH3 C double bond OH, would basically dissociate into CH3 C double bond O minus and H plus. At time t is equal to 0, the concentration has been clearly mentioned to be equal to C2. So C2 at time t is equal to t, it would be C2 minus Y and Y. I have assumed to be Y because X and X cannot be same. So that is why Y has been assumed here. Now writing the equation for this, we get the value of Ka2 to be equal to Y square upon C2 minus Y, which implies Y comes out to be equal to the same thing, that is root of C2 Ka2. Let this be the equation number 2. Okay. Now in the Nernst equation, what are the unknowns? Let us try to see here. In the Nernst equation, first of all, we have been asked to find out the E cell. So that is, this variable has to be found out according to the given question. E naught, I shall be showing you that why E naught comes out to be 0. log q to the base 10 has to be found out and value of n also. So let us try to write the whole cell reaction which is occurring from the anode and the cathodic equations. So anode equation is this one, cathode equation is this one. When we add both of these, that will be the whole cell reaction, because this is half cell, this is half cell. You add both of these, we get the complete cell reaction. So this H2 is present at what? This is present at the anode. This is also present at the anode. Similarly, this H plus is present at the anode and cathode, and this H2 is present at the cathode. So both of these are basically different. The electrons would obviously be the same, so these can be cancelled out. So on adding these equations, you can see that we get H2 plus 2H plus, let me write it for you, H2 plus 2H plus will give me what? 2H plus H2. So writing that once again, so 2H plus H2, where this is from the anode, this is from the cathode, this is from the anode, and this is from the cathode. So this equation is the complete cell reaction which is required for us. Okay, what is the number of electrons n? In the Nernst equation, n has also been asked. So n is basically equal to 2 from here. So n is equal to 2, first variable. The value of E naught would be equal to 0. Now why E naught is 0? Because you can see that both the cathode and the anodes are made of the same material. So that is why E redox would be equal to E oxidation, and hence they would cancel out, giving me the value of E naught to be 0 as in the concentration cells. The next mission is to find out the value of Q, which is the reaction quotient. So what is the reaction quotient from here? So this is the final, this step is a very important step. We have derived the complete cell equation from here. Now you can see from here what is the reaction quotient. The reaction quotient would basically be equal to the concentration of H plus square at the anode into H2 from the cathode whole upon, we have H plus square from the cathode into H2 from the anode. Now what is H plus from the cathode? That is equal to, first of all, anode, so that is equal to root of C1 Ka1, that is the value of X. So we get C1 Ka1 into H2 cathode. What is the given value of H2 cathode? You can see from here that has been given to you as 1 atmosphere, and similarly H2 anode is also 1 atmosphere. So both of these are 1, so into 1 whole upon H plus cathode whole square, which is this thing. So C2 Ka, 2 comes out into consideration here, into H2 anode is equal to 1. Now you can see that this is a very good question from the combination of ionic equilibrium and electrochemistry, which are considered to be very hard. So I hope that this video is making these concepts very clear to you. So this is the Nernst equation. We just need to substitute the values which have been given. We know that the value of n is equal to 2, E naught is equal to 0, and Q is equal to this thing. So just substitute in this equation. We get E is equal to 0 minus 0.0591 upon 2 into log of Q, that is C1 Ka1 whole upon C2 Ka2, that is the log to the base 10. So what is the final correct answer for this question, which has been asked to find out the value of E cell? That is equal to 0.0591 upon 2 log of C2 Ka2 upon Ca Ka1. So this is the value of E cell for this question. So the first part is complete here, that is the Nernst equation. Very basic, a very important question has been discussed here regarding the combination of ionic equilibrium and moreover the electrochemistry, which is one of the most favorites for JEE. So let us move on to the next topic. The next important concept is the feasibility of the reactions. So let us try to discuss this concept here. We have been given E naught for 4 different reactions, Li plus to Li, Cr plus 3 to Cr, Cu plus 2 to Cu, and Ag plus to Ag. You need to find out if the following reactions are feasible or not, the equation number 1 and the question number 2. So let us try to see that how these questions are actually done. So first of all, whenever E naught or any E has to be found out for a particular cell, that can be basically given as E naught of anode for the oxidation part, because oxidation occurs at the anode, plus E naught of cathode at the reduction part. Okay, now it is also given in various forms like minus E cathode oxidation. Now what I mean to say here is that if we have a particular reaction which has oxidation to be occurring has E to be some EX, E star, let me say E star. So whenever for that same reaction, that is the reverse reaction, the reduction is occurring, that would become minus E star. Okay, so don't get confused. Whenever oxidation is occurring for the anode, we take to be this one, and for the cathode we take to be this one. So this is the general formula which is used for deriving any E or E naught, whatever you want to say. So the first question is that we have Ag to go into Ag plus electron, and we have Cr plus 3 electrons to go into Cr. So the thing which I want to make you people realize from here is that Ag0 is going into Ag plus. So what is happening out here? Oxidation is happening out here, which implies this is basically the anode for the given cell. Okay, whatever the question has asked, it is the anode for that given cell. We have the reduction occurring here because from +3 to 0 is happening. So reduction is happening out in this particular case, which implies that it is the cathode. So we have the anode, we have the cathode here. What is the E naught for given as this reaction? We have been given that the reduction of Ag plus to Ag is equal to 0.85. So E naught for Ag to Ag plus, that is reduction का ये दिया है, तो oxidation would be the reverse of it, so that would be equal to minus 0.85 volts. Okay, so this is the case number 1. The case number 2 is this one here. We have the reduction of Cr plus 3 to Cr, that is the reduction at the cathode is happening out here. So that has been clearly mentioned to be minus 0.74 volts. Okay, so we have got both of these two. What is E naught of the cell? E naught is basically the addition of the oxidation of anode potential and the reduction potential of cathode. So that basically is equal to minus 0.85 volts plus of minus 0.74 volts, which is basically less than 0. So if E naught is less than 0, it implies that the reaction won't be feasible. So won't be feasible or basically unfeasible. So this reaction is not feasible. Okay, now let us do the second part here. The second part here has asked, basically this question is taken here to first of all let you know that what is the feasibility, the first reaction is not feasible, and more importantly to let you know that if oxidation has E star, then reduction has minus E star for the same reaction. The second case has Li going into Li plus electron, Cu plus 2 is going into Cu plus 2 electron on this side. So this has been given to you. So here what is happening? Here oxidation is happening, and here you can see clearly reduction is happening. So what is the E oxidation given to you for lithium? You can see that we have been given the reduction potential of lithium to be equal to minus 3.05 volts. So E naught of Li to Li plus would be opposite of that thing, that is 3.05 volts. Now what is the reduction potential given for Cu plus 2 to Cu? So Cu plus 2 to Cu is equal to 0.34. That has been clearly mentioned as the reduction potential. So E naught of Cu plus 2 to Cu has been given to us as 0.34 volts. Now the net E naught of the cell is basically the addition of oxidation plus reduction. So that is equal to 3.05 plus 0.34, which is basically greater than 0. So this reaction is feasible in nature, and the second reaction is feasible. The first reaction is not feasible. What is the reason? There is a thermodynamic reason. Let me make you understand. We know that delta G is equal to minus NFE. At the standard conditions, we would have delta G naught to be equal to minus NFE naught. Now the point to be understood is that from the thermodynamics chapter, that if a particular process or any process is stable or basically feasible, then the value of delta G has to be less than 0. So if the value of delta G has to be less than 0, N is always positive, F is 96500, and then you can see that E naught has to be greater than 0 so that this negative sign balances the total positive in order to give me the final answer as less than 0. So that is why if we want delta G to be less than 0, we want the value of E to be greater than 0. So that is why feasibility would occur only when we would have the value of E to be greater than 0 in order to be the feasible reaction. Alright. The next part taken here is the concentration cells. This topic isn't taught properly, so make sure that you understand it very well. Now this topic actually creates a confusion because of the lack of data. Now what I mean by the lack of data, let us try to understand. For the concentration cells, the value of E cell has been given as 0.029 volts at 298 kelvins. You need to find out the value of N for this given cell, whatever has been mentioned here. But in order to find out the value of N, we know that E is equal to E naught minus 0.0591 upon 2 log of Q to the base 10. This is the basic equation which you all know from the Nernst equation part. But in order to find out the value for the concentration cell, we need the value of, this should be N here, okay. So N has been mentioned for a general equation, whatever we have. Now, if we have in this reaction, let us try to write. So X goes into Xn plus N electrons. The oxidation is happening out here. So this is the equation at the anode. Here we have Xn plus N electron to go into X, which is the cathode. So we have written the half cell reactions for each and every case. What is the total cell equation for here? This is the X which is at the anode. This is at the anode. This is at the cathode. This is at the cathode. So what many people do, obviously, that they cancel out each and every term after adding, but that is totally wrong, because anode and cathode would make the difference, as you can see from the concentrations here. Adding both of these equations, we get X at the anode plus Xn plus at the cathode to give me Xn plus at the anode plus X at the cathode. Now since X is solid, so that is why in the reaction quotient it would have no role, okay, because it is in solid phase. We want only the aqueous and the gaseous phases there, as you remember from the chapter chemical equilibrium. So the basic value of Q, that is the reaction quotient, comes out to be equal to what? That comes out to be equal to Xn plus anode raised to power what? Raised to power 1 only, whole upon Xn plus cathode raised to power 1. So basically that Xn plus at the anode is basically equal to 1 by 20. So 1 by 20. Xn plus at the cathode is equal to 1 by 2. So Q basically is equal to 1 by 10. So our first mission is solved. We have got the value of Q. We know the value of E. E has been given to you in the question as 0.029 volts. So this is known. This is also known. This is the variable which has to be found out. But this question is of the importance here. What is this thing? We have to understand. Now anode and cathode are made of the same material. So whenever a cell is made of the same material, that is the concentration cell, we would have the value of E to be equal to E of anode, the oxidation part, plus E of the cathode, the reduction part. So if E anode is taken to be, let me say, some Y, let me say any variable Y, then you can see that the cathode is just the reaction opposite to it. You take this reaction, you flip it, you get this reaction only. So what does it mean? It means that the cathode reaction is just the reverse of anode. So E reduction of cathode would be equal to minus Y, because we have just inverted this reaction. So if this is Y, this would be equal to minus Y. So that is why whenever we have E concentration cells, basically E naught, that basically comes out to be equal to 0. So this value would be equal to 0 from here. So this was the important point which was to make you understand this question. So we have E, that is equal to 0.029 is equal to E naught minus 0.0591 upon N log of 1 by 10. So that basically comes out to be equal to, this is to the base 10. So 0.029 is equal to 0.0591 upon N into log of 10 to the base 10, that is equal to 1. The minus sign has been reversed by 10 raised to power minus 1. So N from here comes out to be equal to 2. So a very good question which can come for JEE mains and NEET, which we are preparing for right now. Let us move on to the next topic. Electrolysis. It is one of the most confused topics in the entire electrochemistry. In simple language, we can say that it is the reverse of the electrochemical cell. Basically, you need to understand that electrolysis is just the process where we convert the electrical energy into the chemical energy, whereas in the electrochemical cell, we used to convert the chemical energy into the electrical energy. So that is in layman terms. Let us try to understand the very important question which I am taking here. Please focus, it is a very important question. You would understand now that why it is important. The first part here is that you need to find the equations at the cathode and the anode for the electrolysis of molten NaCl and aqueous NaCl. So first of all, you need to understand that what is the difference between the molten NaCl and the aqueous NaCl. Molten NaCl means that there is no water present in the solution, whereas aqueous itself clarifies that there is water present in the solution and the electrolysis of water can also come into consideration. So first of all, let us take the molten NaCl. So we know that NaCl is basically Na plus and Cl minus. So at cathode, where the reduction would occur, how the reduction would occur, you can see we have Na plus, okay, that would react with the electron in order to give me Na in the solid form. That is happening at the cathode, where the reduction is basically happening. At the anode, what would happen? See, you have to react Na plus and Cl minus because we have NaCl. So we have to react Na plus and Cl minus instead of reacting Na or Cl2. Okay, so that logic should be understood. Now we have Cl minus. The oxidation of Cl minus has to occur. So Cl minus would basically oxidize into Cl2. So we need to take 2 Cl here and the 2 electrons in order to balance the equation here. Now this is the equation at the cathode and the anode. In order to get the net equation, we have to multiply this equation by a factor of 2 here. So we multiply this by 2 in order to get the 2 electrons to be cancelled out, giving me the net equation as 2 Na plus 2 Cl minus goes into Na solid plus Cl2 in the gaseous phase. So this was a pretty easy part which is known to you, but still people get confused because they write the equation of this in the reverse reaction and claim to happen at the cathode. But we need to consider these as the major things. That is why Na plus is reacted and Cl minus is reacted according to the given question. Now comes the very important part, aqueous NaCl. Before understanding the aqueous NaCl, you have to understand that water can also have the oxidation and reduction. Now how that can happen? Let us try to understand in the part number 2. So whenever we have H2O, that is the aqueous part is taken into consideration, the aqueous NaCl. So reduction can happen in the following manner. We have H2O, okay. Now in order to reduce it, we have the oxidation state of water to be H to be 1 here, that is oxidation state of H is 1 here plus 1. In reduction it would go to 0. So basically we get H2 here. Now in order to balance the O, we have to take the OH minus. In order to balance the negative charge here, we take the electron which is present. Now we have 3H and only 2H. So I do it half in order to give me 1H and 1H from here in order to balance the equation. So whenever water is there, the reduction at the cathode can happen in this following equation. Now oxidation can also occur because we have the cathode and anode. So oxidation would occur at the anode basically. So how the oxidation would occur? Try to understand. We have H2O. The oxidation state here is basically equal to +1. We have the oxidation state of this to be equal to +2. That is quite understood here. This to be -2, I'm sorry. Oxygen is basically -2. So in order to oxidize oxygen, we need to convert it into O2 because we have the oxidation state to be 0 here. So you can see that oxygen has oxidized into O2. And here we have the presence of 2H plus. And you can see we get the 2H2O. We need to balance. So we get 1/2 oxygen. Then we get H2O. Now balance the charges. So what are the charges? We have 2H plus here. We have 0 as the net charge. So we need to add 2 electrons in order to make the charges as balanced. So what I mean to say is that the electrolysis of water occurs in the reduction form at cathode in this manner, in the oxidation form at the anode in this manner. So these two equations should also be taken into consideration. Now we have the aqueous NaCl. Let me write it for you. Now understand this question very well. It is a very important part. We have aqueous NaCl. So at the cathode position, the cathode where the reduction would occur, in the previous case as we had seen, we have the presence of Na plus. Similarly in the cathode, here we have the presence of Na plus and H2O. Only Na plus is not present. We have the presence of H2O also. Similarly, at the anode position, we have the presence of what? We have the presence of Cl minus and H2O. So this factor should be taken into consideration. Here we had only Na plus and Cl minus, so it was quite clear what is going to happen. But in the aqueous NaCl part, we have to consider the presence of water also. Now there is a series called order of deposition. Let me write it for you. Whenever we have the cathode, basically I mean to say the cation position here, not the cathode. For the cations, the order of deposition basically Li plus is less than K plus is less than Na plus, moving on till is less than H plus. Okay, so what I mean to say is that for the given cations and moving on, the last term comes as Au plus 3. The factor which I want to take into consideration here is that the deposition rate of the H plus cation is greater than the Na plus cation. So what does it mean? It means that at the cathode, the Na plus wouldn't be the reacting species, but instead H2O would be giving the reaction. Okay. Similarly, at the anion position, if you see, if we have anion, at the anion position, we have the rate of deposition order as SO4 minus 2 is greater than NO3 minus 1 is greater than OH minus 1 is greater than Cl minus is greater than Br minus is greater than I minus. So what you can see from here, the rate of deposition in ions of OH minus is greater than Cl minus. So in this case also H2O will win because electrolysis is basically the deposition. So what I mean to say is that at the molten NaCl you got these two equations, but let me tell you what is going to happen at the aqueous NaCl. It is a very important part. So at the cathode, which reaction would be occurring? H2O reaction would be occurring. So how H2O dissociates at the cathode has been mentioned here. So it would go as H2O would give me H2 plus OH minus, balance it out, we get 2H2O, 2OH minus is balanced by 2 electrons. So this is the equation which is happening at the cathode. At the anode, we would have the equation once again, H2O wins over Cl minus because OH minus has more deposition rate than the Cl minus. So here we get H2O to be oxidized into O2 plus here we would have 2H plus 2 electrons and half O2. So you can see that when we had considered a very important topic, when we had considered the electrolysis for the molten NaCl, because no water was present, so these were the final equations of cathode and anode. But in the aqueous NaCl, when we had considered the electrolysis, due to the deposition rates which I have told you here, the deposition rate of H plus was more than Na plus, so thus H2O was taken into consideration. At anode, the deposition of OH minus was greater than Cl minus, so that is why we have to consider at the anode the OH minus occurring here. So that is very important here. I hope this point is clear to you. Now I am taking a simple question here to make you understand the involvement of mathematics in the slope form in this chapter. So basically a graph is plotted between E cell and log Zn plus 2 upon Cu plus 2. The curve was linear with the intercept on the E cell axis equal to 1.1 volts. You need to calculate the E cell for the given cell. So first of all, what has been mentioned, let us try to see. Graph is plotted between E cell and log of Zn plus 2 whole upon Cu plus 2. So this is the y-axis, this is the x-axis. So what is the relation which you know about these two cells? Let us try to write the cell equation, which I have told you. Whenever electrochemistry question aata hai, the first mission should be to write the cell equations. So we have Zn, which goes into Zn plus 2 electrons, which is happening at the anode. At the cathode, we would have Cu plus 2 electrons to give me Cu, which is occurring at the cathode. Okay. Now adding both of these equations, we get the value as Zn plus Cu plus 2. See, the ions are always in the aqueous form, otherwise they won't be stabilized. And Zn plus 2 aqueous plus Cu. Okay, so the relation between E cell and log of Zn plus 2 upon Cu plus 2, we all know is that, which is that the Nernst equation. So we have E cell to be equal to E naught minus 0.0591 upon n, let me write n only, log of Q to the base 10. So E cell is equal to E naught minus 0.0591 upon n. N is equal to 2 here, that is the number of electrons, log of Q is basically equal to Zn plus 2 whole upon Cu plus 2. Okay, so this is the equation which has been given to you. Let me assume that this is some y and this is some x. So you can see that this is a straight line which has been clearly mentioned to you in the question that the graph was linear. So we have assumed the equation to be correct here. Now we need to calculate the E cell for this reaction. So for calculating the E cell, we first of all know the value of E naught also. The E naught is basically equal to 1.1. How is it equal to 1.1? Because when the graph would intersect the y-axis at any point, at that point it implies that this value has to be equal to 0. So if this value is equal to 0, basically if the thing I am hiding that is equal to 0, so E cell would be equal to E naught. So E naught comes out to be equal to 1.1 volts as given in the question. So we know that E cell would be equal to 1.1 minus 0.0591 upon 2 log of Zn plus 2 has been given to us as 10 raised to power minus 1 and Zn and Cu plus 2 has been given as 0.01. Substituting the values, we get 0.1 upon 0.01. So E cell is equal to 1.1 minus, see I'm calculating just for you, otherwise I could directly move from here to whatever step that is, into log of, now this thing becomes 10 raised to power minus 1 upon 10 raised to power minus 2. So that basically becomes 10. So log of 10 to the base 10 is equal to 1. So E cell finally comes out to be equal to 1.07 volts. So this is the correct answer for you. Okay, I hope that this question is clear. Now we discuss a very important part, that is the Faraday's law of electrolysis. I'm not deriving the equation for you. In the I button I place the link for the entire electrochemistry series. So if you are not clear that what is actually happening, or if you're confused, you can obviously watch that. That is very helpful. But since this is a revision video, you all know that W, that is the amount deposited, is equal to ZIT, where Z is also equal to equivalent weight upon 96500. I is the current in amperes and T is the time in seconds, that is the SI units that we take into consideration. Now this is a very good question which I am taking here because it will clear everything in this topic, the Faraday's law of electrolysis, a very important topic for boards also. The question here is that silver is electrodeposited on a vessel of a total surface area 800 centimeter square by passing a current of 0.2 amperes for 3 hours. Okay, so first of all, SI units are the mission. Calculate the thickness of the silver deposited. Density of silver is 9.67 gram per centimeter cube. So first of all, let us try to see that what has been actually done here. So we have been given the surface area is equal to 800 centimeter square. The I, that is the current, has been given as 0.2 amperes. Time t is equal to 3 hours, that is basically 3 into 60 minutes into 60 seconds. So we have converted everything in the general form. Now we need to calculate W is equal to ZIT. The thickness has been asked. Before that, try to understand a very simple thing here. We need to find the value of Z. Z is equal to E upon 96500, where E is equal to molecular weight upon N factor. Okay, now we have silver. Silver is what? Ag. So Ag basically goes into Ag plus electron, or the basically the reverse thing, whatever. But the N factor would be equal to 1 because we have only one electron to be involved. So the weight, the equivalent weight is equal to molecular weight of silver, which is equal to 108 upon 1. So E is equal to 108. So the value of Z comes out to be equal to 108 upon 1 whole upon 96500. We have got the value of Z from here. We know the value of I from here. We know the value of T from here. So basically 3 things are known to us. So we can calculate the value of W, that is basically the mass, in layman terms weight, is equal to ZIT. So Z is equal to 108 upon 96500 into I, which is equal to 0.2 into 3 into 60 into 60. Okay, this is the calculation which you have to do. I have the answer with me, so let me just directly write instead of wasting time on it. So the mass basically comes out to be equal to 2.41 grams. Okay, now the question has been asked to find out the thickness of the silver deposited. These type of questions are favorite for mains and NEET. Okay, so I hope you understand it. Thickness has been asked where the density has been given to you. So what is density? We know that density is equal to rho, which is equal to mass upon volume. So rho has been given as 9.67 in the question. So 9.67 is equal to mass, that is 2.41 upon volume. Now see, this is in gram per centimeter cube. If you're confused in the units, this is in gram per centimeter cube. So I've written the unit here. 2.41 is in grams. So gram and gram gets cancelled out. The volume comes out as 9.67. Sorry, volume comes out as 2.41. Volume is taken here. Upon 9.67, centimeter cube goes up, centimeter cube. So don't get confused between the units that meter cube are as centimeter cube. So this is the answer here. Now the volume has been found out. Now what is volume? Volume is mathematically is equal to surface area into height or thickness, because this is in centimeter square, this is in centimeter, so that gives us the volume. Surface area has been given to us as 800 centimeter square. So volume is equal to 2.41 upon 9.67. Surface area is equal to 800 centimeter square into thickness. Let me write as thickness. Everything is done in, this is in centimeter cube, centimeter square. So this would be centimeter only finally, the thickness. So thickness comes out as 0.0312 into 10 raised to power minus 2. In the SI terms, this can be written as thickness to be equal to 3.12 into 10 raised to power minus 4 centimeters. Okay, I hope that this question is clear to you. There are no doubts. If there are any doubts, kindly ask me. Okay, now let us move on to the next part and the last part, which is very important here. Now let us try to understand the electrolytic conductors here, where we shall be dealing with the very important lambda m and lambda e. Before moving on to that, you should understand what is the difference between electronic conductors and electrolytic conductors, so that it is quite clear for the physics chapters also. So in electronic conductors, the flow is due to electrons. The flow is due to the electrons. There will be no decomposition of any electrolyte. That is, if you take a pipe, you flow 3 electrons from here, then 3 electrons would be coming back like the normal conductors we have. So there will be no decomposition of the electrolyte. On increasing the temperature, the resistance would increase, that is R is equal to rho L upon A. Okay. Now the electrolytic conductors, which is of importance for electrochemistry here, are the ones where the conduction is due to ions, as you studied in Ionic Equilibrium also, and the combination of these two chapters, that the conduction is due to the ions. When the current is passed, there is decomposition of the electrolyte. How there will be the decomposition of electrolyte? अभी तो पढ़ा जैसे हमने Faraday's laws of electrolysis, that there is a decomposition of electrolyte. That is why that law exists. Okay, so on increasing the temperature, the resistance would decrease because there will be the more production of the charge carriers, or basically the ions. Let us move on to the important parts, which are the mathematical ones. So you need to understand that if we have the basic physics is quite clear, I shall not be discussing that. Let me discuss about the mathematics. So we have lambda m, which is known as the molar conductivity. Now these two formulas are very important. I shall be taking a very important question also, so please make sure you understand it. We have lambda m, which basically is equal to 1000 K by m, where K is the specific conductivity and m is the molarity or the concentration for the given solution. Okay, as simple as that, just a formula has to be used. Now if we take lambda e or lambda n, whatever notation you want to use, that basically is equal to 1000 K by n. Now since we have n, that is normality here, so this is known as equivalent conductivity. Okay, and this once again is the specific conductivity, and n is the normality here. What is the relation between lambda e and lambda m? We get the value of lambda m to be equal to n into lambda e. Okay, I hope it is clear to you. Where n is the n factor and all that stuff, just the basic mole concept we are taking here. Now comes the very important questions here, so let us discuss them. So we have to write the values of lambda m naught and lambda e naught for AlCl3. So kindly understand this question very well because it will help you clear a lot of stuff. I placed the link for the entire electrochemistry playlist in the I button, so make sure you check it out. So we have lambda m naught of AlCl3, that basically would be equal to summation of all the ions. So here we would have lambda m naught of AlCl3 to be equal to lambda m naught of Al plus 3 plus lambda m naught of Cl minus into 3. 3 is multiplied because we have 3 Cl here. So in lambda m naught we have this value. If we take the lambda e naught of AlCl3, that would basically be equal to lambda e naught of Al plus 3 plus lambda e naught of Cl minus. There will be no multiplication of any factor of 3 or whatever is present. So what I mean to say here is that whenever lambda m naught has been asked, we directly multiply with the factor which is taken into consideration. But when we have lambda e naught, there will be no multiplication of any factor here. So this should be quite clear to you that how we have actually done it. Okay, now the very important law where the question has been asked, let me draw the graph for you. This graph is very important. We have lambda m graph versus root C graph which is present here. Let me draw one line with the help of the red color and the dark one has been shown here. Okay, now this is the graph between lambda m and root C. There is a very important law which is given by Debye and Huckel that lambda m is equal to lambda m at infinity minus b root C, where b is a constant. So this was given by Debye and Huckel, a very important rule. Okay, I hope that this is clear to you. It is given in the NCERT also. So very important for mains and NEET. Now this is the equation which has been given to you. Now the red one which I have drawn here is for the weak electrolyte. Weak electrolyte, as we had studied in the Ionic Equilibrium chapter, the straight line which I have shown here is for the strong electrolyte. So this graph should also be remembered by you. Okay, so this completes the very important electrochemistry chapter where I have dealt with all the important parts for this chapter. Make sure you have liked this video because that is the major confidence booster for me. So make sure you subscribe to the channel because I take the polls regularly so that you people can select the chapters according to your wish. So if there are any doubts, kindly ask me in the comment section. So thank you and all the best.